Hi, can you guys hear me all right out there? Awesome. So there's my Twitter handle up there for those of you who like to live tweet these kinds of things. My sticker is yellow, but while I'm up here, you're free to take as many pictures as you want. A little bit about who I am. I am a DevOps kind of person. I do a lot of code review day to day. I'm looking at patches other people have written, I write a couple of my own, and while I'm looking at these patches, I tend to look through and try to find whatever bugs I can find in there. Looking at a diff and saying, okay, what code is this touching? How can I find out how it might break? And if it's not going to break, then cool, I'll approve it and it'll then eventually end up in production. Sometimes I miss bugs and they end up in production, and I end up trying to debug things in production, looking through code, trying to figure out what happened, and in general, just trying to debug the code. Sometimes I fix the code. Sometimes as I'm fixing code, I introduce new bugs. We all write bugs, that's part of what this is. And so how do you write debuggable code? How do you write code that is easy to find the bugs in? A big part of that is writing familiar code. If you're familiar with the code base, then it's going to be easier to be writing code that others can understand and others can debug. So as you're trying to write a patch, it's really important to read a lot of the code before you start adding to it. It's really important to familiarize yourself with the code base as you're writing the code. It's kind of obvious that you need to read some of it before you start writing a patch. If you just add functions to a code base, you can't really expect it to run or do anything. But you need to read more than just that. You need to really familiarize yourself with the classes that are being invoked, the APIs around those, and try to get an idea of how it all works together, how it all fits together. And once you have that larger understanding, then you can start writing code that can easily be understood by others, and others can start debugging the code that you're writing. It's important to have the experience with the code base, but it's also important to have experience with general code patterns, design patterns. There's a great book out there called Design Patterns that talks about different types of ways to write code. And having that background really makes it easier for others to understand your code. If you come across a code base that you don't really understand that well, then start talking to the developers about it. Start a dialogue about what does this do? How does this work? Start getting involved with the community if you're having trouble understanding it. And then you start really writing better code, and you start writing code that others can really understand. You can write code that you can understand yourself. I know that for myself, when I write a patch, I can usually remember how that patch works for about 6 weeks. After that, if I need to go debug it, I need to figure out how it works again. I need to figure out what this code base was doing again. And so keeping that in mind, you just got to keep reading things and rereading things, familiarizing yourself with it again and again and again. And eventually you start to write code that others can understand. It's really important that you write code that's easy to understand in order for others to find the bugs. But there is a pitfall here. As you become more and more familiar with the code, you can start making a lot of assumptions about, oh, I know exactly how this works. I know exactly what's going to happen here. And those assumptions are going to make it harder to understand what's going on. So as you're writing these things, you need to be aware of what's going on and really, it's really important that as you're writing this, you're paying attention to what the other people are going to be thinking as they're reading it. To help that, it helps a lot to write simple code. To have a modular design with the Unix philosophy, you're going to be having small, concise pieces of what's happening. When things start getting large, you got to break them apart. You got to tease things apart as much as you can. When things get large, you might need to break them up into separate modules and define an API there, and then start documenting that API. And as you create these APIs, it helps a lot to keep things as simple as possible. I really can't stress how important it is to keep things modular and small and simple, and it's really hard to do. It's hard to keep this, to be mindful about this kind of thing. But having these things be modular makes it a lot easier to narrow down on where this behavior is happening. So as you're trying to debug something, you can say, oh, I know exactly which module this is happening in. I know which class this is because I'm familiar with the code base, and I know how these functions work together. And then you're able to really like have a semantic scope to where the behavior is happening. And so, this bug is happening when I call function X or function Y. And you're able to say, okay, I know exactly where that function is happening. I know which classes that's coming from. And you're able to really drill down into where that bug could possibly be. And then you have a much smaller chunk of code you're looking at, rather than like looking across 3 classes and 4 different modules and being like, well, okay, I don't know where this bug could possibly be happening. But if it's nice and modular, you know exactly where the scope could possibly be. So as you keep it simple and modular, it's really going to be easier to debug. It's also important to limit the abstraction you're creating. As you add abstraction, you add ways that bugs can hide in your code. It's really important. Sometimes you really need the abstraction, but it's important to keep in mind that that abstraction is going to have a cost. That cost is going to be developer time and effort as they're trying to find bugs. And it's a lot easier to find the bugs when you're not going through 3 levels of object-oriented abstraction of like, okay, well, this inherits that and that inherits this. And you're trying to figure out which of these classes might possibly be running the function that has the bug in it. So as you're trying to add this abstraction, it's important to keep that in mind that it might be a hindrance as well. It's also important to limit the magic you have in here. By magic, I mean, like, the magic comes from the assumptions, really. The magic comes from knowing what's going to be inside of that dict without inspecting it. The magic comes from already knowing what functions are going to be calling this function. And if you have a lot of magic there, then it's going to be really hard to figure out where the code path is going. If you have a lot of magic, it's going to be hard to figure out what exactly is happening and where the bug could be introduced. So as you're removing the magic, as you're making things simple and easy and documented, then you're really making it easier to quickly narrow down on where a bug could be. It's really important to be explicit. A lot of the magic comes from the implicit assumptions we're making. So as we're being explicit about it, as we're being explicit about what functions are being called and what classes are being inherited and where the mix-ins are really like mixing in the different classes, then it's a lot easier to just track down the bugs within those classes. And so as we have simple code and as we're familiar with our code, we really end up with a clear and concise design. Again, modular design. It's really important that things are small and scoped and you can really quickly narrow down where the behavior is coming from and not having to hunt for where the behavior might be coming from. Comments go a long way. The more you comment your code, the easier it is to figure out what the code is doing. I don't want to have to like stare at 50 lines of a function to figure out what logic is supposed to be happening and what logic might be buggy. If there's a comment that tells me what the function is supposed to be doing and what order things are supposed to be happening in, then it's a lot easier to know if the logic is correct. It's a lot easier to tell, okay, I know already what this function is supposed to be doing, and is it doing what it's supposed to be doing? Or am I trying to figure out what it's doing and if that's correct? And one of those two is a lot harder to debug. If I'm assuming the code is correct, then it's a lot harder to tell if this is a buggy piece of logic or not. But if I have a comment telling me what the code is supposed to be doing, then I know already, okay, this is supposed to be checking out the master branch first. It's supposed to be looking for some other ref that's not the master branch. And I can look through the fallback logic to figure out if this is happening the way it's commented or if it's happening in some other way. And along that same line, doc strings go a long way too. Doc strings are somewhere between comments and documentation. Does everyone here know what a doc string is? A comment at the beginning, a string at the beginning of a function that kind of defines what it is? Cool. Yeah, if you have the doc strings that define the function and its API, then that goes a long way too, of telling you, okay, these are the things that I'm expecting the function to take, and these are the things I'm expecting it to return. And I can tell if it's returning an empty string versus a none whether that's going to be buggy or if that's intended. I can tell if it's supposed to be in the API or if this is a break of the API. And that way I can tell, okay, this behavior is expected, and that is not really a bug, or this behavior is not at all what's supposed to be happening according to this doc string. And now I know this is a likely candidate for where the bug is coming from. But it's not always easy to keep your code simple. Sometimes the problem space is really complex. Sometimes you're trying to code a discrete in time Fourier transform, and that's not going to be an easy piece of code. That's not going to be something you can just look at and say, oh, I know exactly how this is supposed to work. And that's when higher level documentation really comes into it, when it's really important to have some documentation that tells you the architecture of the solution, some documentation that tells you what the program is intended to do, how it's approaching the problem, and really how it's designed. Having the design documentation goes a long way for helping us figure out where a bug might be in the code. So, print statements. This is a great way to get some debuggable code. For writing some code, we can easily say, okay, let's add some print statements. Let's print out entering loop every time we're entering the loop. And that tells us, okay, we know where the code is. We know what the state of the internal machine is. And that's a great way to start writing debuggable code. You can start saying, okay, I'm going to document that at this iteration of the loop, I know what the contents of my dictionary are. And in some ways, this is kind of newbie code. It's like, well, okay, I'm going to be in CS 101, and I'm going to enter some print statements into my code so I can figure out what the loop is doing. But really, we never stop doing this kind of thing. We're always going to be entering these print statements. We're always going to be saying, okay, this is the state of the machine, and I don't know what that state is unless it tells me. I don't know what the values of the variables are unless I'm printing them out. And it's also important for those messages to be unique. You need to know which print statement you hit. If you have 3 different print statements that are just entering loop, then you don't know which loop you're in. You don't know what iteration of the loop you're in. You need to be able to say, okay, entering loop 1 at iteration 3 to know exactly where you are in the code. And that, if that's where you hit your bug, then okay, you know it happens at the 3rd iteration of the first loop. But if you're just saying, okay, entering loop 1, and then that's all you're doing, then you're going to get that message every time you iterate through that loop, and you're not really going to have an idea of where the bug is coming from, which iteration it's coming from. You're not really going to know which function you are in if you just have entering function at the beginning of every function. But if you say entering function foo, then you know you're in function foo. If you have entering function foo and my arguments are x, y, and z, then you know what the state of function foo is as you're entering that. And it's really important for these messages to be unique and concise and to really drill down on where they're coming from. And eventually we get even better at print statements and we start to import logging. Importing logging is a great way to get better information out of the system. You're able to say, okay, I only want things at a warning level. You can import logging, and then logging.warn will print it out at that level. And as you start getting better at this, you're able to really determine what's happening in these systems with these specific logging statements and sending these to different kinds of files. So you know you can watch your error log file for the errors, and when you hit an error, you can go look at the debug log file and say, okay, these are all the messages I have at my debug file. Okay, so I know that in my debug log, I have entering loop y at state z, and I can say, okay, now I know what the state is of the system when I entered this error state. And I can drill down and figure out what could possibly be causing that bug because I know the internal state, I know where I was in the code base, and I can really focus down on which module that's coming from. I've got a couple of guidelines here for some logging levels, I think it's really important that we kind of define what we're using each level for. We really only want to have unforeseen states and broken behavior in our error logs. Our error logs should tell us that there was an imminent failure and the program is about to crash, or there is some broken behavior in the API and some dependent program is about to crash because we didn't really understand what was going on. The developer did not foresee this state in the machine coming along. And that's really all that should be happening in the error level. This is really intended for the users and operators of the program or system that you're using. The users and operators are also going to be concerned with the warning level, which is more about exceptional states and exotic use cases. An exceptional state is going to be some exception that you could possibly recover from, something that might lead to an error or might not, something that is a little worrisome. And it also talks about exotic use cases, which is things that should work but might not be tested, things that might be what people consider hacks, like, oh, it's not really intended to do that, but it probably works anyway. And it's like, well, warning, I'm not really sure this is supposed to happen, but it's going to just keep going anyway. At the info level, we're finally getting to things that are a little bit more interesting. The testers of the software are really going to be interested in this info level. We're going to have some standard operating events. We're going to have things along the lines of responses to API events. We're going to have responses to input that comes from the user. And we're going to say, okay, we're acknowledging that we're in this state. This is a normal state, and we're going to keep moving through it. And it starts getting noisy there, but it's still really useful information for the operators at times. It could also be said that it's useful for the users because they might want to know that their input was received, or they might just see the program act normally and that's all they need to know. You could also make a case that the developers really want to know the info level, but only when the program is running normally. When you're debugging something, you're really focusing on the debug level. That's what it's there for. The testers and developers are going to be drilling down into this debug level of what is the internal state of the machine? What were the arguments to the functions I was calling? It's surprising how often heartbeats get munged all over the place, though. As I'm debugging problems, I usually see these things shuffled all around, and I end up with like, oh, thread 2 waking up, all in a warning level sometimes, usually an info of like thread 2 waking up, nothing to do, thread 2 going back to sleep. And this just repeats every 10 seconds or 30 seconds or whatever this loop is going to be doing. And that makes it a lot harder to debug what's going on because I need to sort through all of this just to figure out if there was an API event. It's a lot easier to debug this kind of thing when all of these are in their own little category and they're nice and compartmentalized. That's pretty much all I have at this point. Do we have any questions? Anyone want to talk to me about why they think this might be wrong? Well, I think that if you keep things modular and keep the scope really small, then that becomes less of an issue. Because as you keep things small and modular, they become a lot easier to test. You're going to have small unit tests. You're going to have easy to understand functional tests because you know exactly which piece of the code you're testing. You know which code path you're going through. And yeah, you're going to need to have information from both the info level and the debug level to get through that. But I think it's also important to separate those out to the point where you have normal behavior and you have internal state. Does that make sense? Any other questions?
So, and I think I may know where you'll go with this, but in other languages, I think you almost have like a debug vector set for the bits to say, I want these messages on, not these other ones, to get flooded. And here you just have a core level. Is there some way that you maybe have more
I can definitely see cases for adding deeper levels. Like I've seen trace level deeper than debug, but I don't really see much of a use for it. I haven't needed it myself. I haven't seen it be helpful when I've been trying to debug something. Is there a particular kind of...
I'm thinking of cases where, well, I suspect it's here, I want more information in this section, but not in that section. So you don't want to just set the debug level.
Oh, so you're thinking about having debug levels for particular modules and... Okay, yeah, that's definitely possible with the Python logging module. You can set the level for different modules. So like when you import requests, you usually want to turn that down to warn and not have any of the info level there because that gets really noisy really fast. And so you can definitely do that with different modules having different levels. But that either... Well, can you explain again what...
Saying that you have a single global resource, maybe where you say, you just turn it on. It might even be within the same model. It might
Oh,
functions, not others.
no, there's no function granularity with the Python logging module that I know of. Or is... Yeah, you can have multiple loggers and you can have multiple things going to different files. So yeah, if you have your own project that has like modules and submodules, then you can have specific submodules go into their own log files, and that's definitely doable, and have those be at different logging levels. No, and that's mostly because I tend to be debugging stuff in production, and it's troublesome to add PyDB into a production system and be like, okay, what's going on here? So I tend to rely on analyzing the code and analyzing the log files. Say that again? PUDB? I'm not familiar with that. I'll have to look it up. Okay. And so that gives you a deeper insight into what the internal state is? Oh, it's faster? Okay, awesome. Oh, awesome, yeah, because GDB is pretty cool. So that would require a change in the code? Okay. Any other questions? Yeah? So you can configure it a lot of different ways. The basic configuration is to put everything into a single level. What I tend to do is have things split up so that I have only error and warning in a single file, and then I have another file that includes info and debug, and it has all 4 levels in there. So I don't have to look at 2 different log files. I can be like, okay, if I find it in the error log, then I know where to look in the debug log, and I can see the error right there beside the internal state coming from the debug log. Is there a question over there? No? Any other questions? Yeah? It depends. That's a difficult question. Yes, the logging lines in the code can make the functions larger, harder to see everything at once and try to figure out what's going on. But I also think that if you keep your messages simple and unique, then that's going to be less of an issue. If you have like 3 small messages, that's going to be easier than one paragraph that's telling you something. Any other questions? Cool. Thank you.